if you close your eyes and you imagine when you hear a mosquito flying around your head, your ability to be able to very clearly place that mosquito in a 3D space is based on your temporal resolution at 5 microsecond resolution, and the arrival time difference between the sound of that mosquito flying around in your left and right ear. It's that natural binaural or 3D perception of sound. Once you break it down and you make that 96 kilohertz, all of a sudden that sound stage goes whoop and narrows down, both in width and depth. And your ability to be able to recreate that depth of sound in a digital environment is completely destroyed. Hence, now all of this interest in immersive audio from L Acoustics and DMB and all these other companies, because they're saying stereo's no good. Doesn't work. There's no depth and no sound. You can't determine where something is in the sound stage.
Welcome to Audio Technology Magazine's ISO Booth podcast, where we phone audio engineers and producers at home, and thanks to the pandemic lockdown, they answer.
Welcome everybody to the latest edition of Audio Technology's ISO Booth. Today on the line I have front of house mix engineer extraordinaire Angus Davidson. His other hat that he's been wearing over the last few years is technical support manager or director, Angus?
Director.
For Nth America APAC. So, welcome, Angus.
For KV2 audio.
For KV2 audio, indeed. Thank you. That was a very crucial bit of information that I failed to provide. So just as we launch into this, I just wanted to set this conversation up a little bit to make sense of it for people. And I want to be as transparent as we possibly can with this interview. So last year you shared with me an article that was basically an impassioned case for point source loudspeaker technology and how we'd pretty much all been caught in thrall of the line source alternative, even when at times it's clearly not the right choice. But more than that, your case was focused on a particular manufacturer of point source, and no surprises to who that might be. That's KV2 audio. So there was one tiny issue of credibility with this article that I had a bit of an issue with last year, given your current role. Or not credibility so much as a conflict of interest. So saying that, I found your article really, really interesting. And knowing you the way I do, I knew that you'd written that article with a lot of integrity. It wasn't a sales pitch. It was more intended as an industry wake-up call. And in this case, you genuinely believe you're working for the company that has the answer. I believe that myself. So I thought I may not have in good faith been able to publish your article in that format, but as a Skype chat, it's a great way to hear you out and allow our readers to make up their own mind. So I know it's a bit of a long-winded preamble, but I just really wanted to make that clear. So let's talk about large format point source versus line array. Where did it all begin for you, Angus?
Well,
to give us a little bit of a background, let's just quickly walk through the 70s and 80s with Angus.
Yeah, okay. I guess actually just to preface what you said, it's not about point source.
Okay.
Point source is a big part of the equation as far as I'm concerned.
Yep.
But it actually has a lot more to do with the overall signal path that we find is common now.
Yeah.
And that's changed dramatically since I started in the industry back in the 70s. So whilst point source is fundamental to what I believe a good audio outcome is, it's largely dependent upon ticking a whole lot of boxes along the way, and one of them is how you're processing the signal, because what we hear now is fundamentally determined by not just the speaker system that it comes out of, but all of the processes that the audio goes through from the source to when it comes out of the speaker system.
Yeah. Yeah.
So I guess that I covered that in the article, going back to my early days in the mid 70s when I started working with some guys here in Melbourne as a roadie. Started off doing lights and stage actually, but then met some guys who, one in particular, Kai Dahlstrom, who had set up a small recording studio called, well, in those days it was called KAJ Recording, in his house in East Melbourne. It started off as a rehearsal room, and then he put a little control room off it, eventually moved to Gordon Street, Richmond, and became the incredibly successful and well-known studio Sing Sing. And I became involved with Kai in the original studio at KAJ in Gordon Street, which again was part of a facility there, which was a rehearsal room, and we put a control room in there. The decision was made that we'd expand the studio, and so we took on, I should say, the other half of the building there, and decided to completely redesign and rebuild a studio on a much bigger scale. And that was how we started what became Sing Sing. Mm-hmm. And in those days, obviously, that was all sort of pre-internet. So, I set about researching, what would be the best format for a control room environment. And I'd got a subscription to a magazine called Audio, what's it called? Audio
so
Engineer.
Generic, yeah, so generic you can hardly remember.
Yeah,
a bit like
Audio
audio
Engineer.
Technology.
Yeah, Audio Engineer Producer, I think it was called. But anyway, there was a magazine released in 1979 where they had an amazing article on phase relationships in speakers, and they tested the old URI 811A speakers, which were based on an Altec, and using a new process from a company called Crown called TEF, which was time, energy, frequency. They'd gone in and started doing very pointed testing on what would happen when you took an HF frequency, an HF driver and a bass driver and changed the phase relationship. And it illustrated very clearly that there was dramatic damage done to the signal. And that's a very brief and very sort of shallow overview. But essentially what it taught me was that phase relationship in sound was critically important to high-quality sound reproduction. And it was something that could only really be done 100% with a point source, because obviously, in a situation where you've got a coaxial speaker, it is a true point source. The HF and all of the frequency below that emanates from the same source. Of course, when we look at, I've got a studio here full of speakers which are not point source. I've got PMC and focal, which are all multi-source. But I guess the situation with that is that they're all generating a band of frequencies that are not overlapping. So from that point of view, you do get generally a very good result. But anyway, so when we decided to look at this, and I looked at how it had been applied in that first instance, it was in a new concept called live end dead end rooms, or lead rooms, which essentially flew in the face of the conventional wisdom in those days, which was to create a speaker source with hard surfaces, diffuse surfaces, to reduce the amount of phase interference between the speakers and the listener, and then the space behind the listener was highly absorbent, which was then that absorbency was manipulated to create the flattest possible response. Now, the problem with that was that your stereo image was very, very narrow, and you could hear a lot of phase anomalies when you move to the left and right of your dead center. So Live and Dead End addressed this by creating a front space that was extremely absorbent, so there was no early reflections from the front of the room, but the back of the room used what the same technology that's been employed in the designs of auditoria over hundreds of years, which employs the Huss effect, which means that audio that you hear is a reflection from the direct sound from within around 18 to 25 milliseconds. There's no apparent change in the source of the audio, which means that the speaker, the sound would go past the listener, bounce off a diffuse field in the rear of the room, and then arrive at around 3 dB lower than the direct sound. But psychoacoustically, you weren't able to determine that it was coming from the back of the room. It sounded like it was coming from the speakers. Gotcha. So I looked at that and I thought, this is a brilliant concept that ticked all the boxes for me, and employed very specifically the technology that had been looked at by Synergetic Audio Concepts in the Jet Propulsion Laboratory back in that 1979 article. And look, that's probably sounding a little bit complex and gobbledygook, but we don't have a lot of time. So that fundamentally framed my position as far as what I thought was a great outcome from an audio point of view in a studio. And of course, the benefits of this is, what you're attempting to recreate or to create by that diffuse sound field was what they do in theatres and in symphonic auditoria, is create a 12th octave comb filtering effect, which is so fine that your ears can't determine that it is actually comb filtering. It sounds flat because it's so diffuse. And what this then allows the ears to do is to hear this reflected sound as a part of the original sound, but it broadens the listening centre dramatically. So it means that as you move to the left and right, you're not getting these anomalies that you would normally hear in a Westlake style studio where you're moving in and out of that audio field, that sound field. You get a much broader, more, if you like, symphonic auditorium style listening experience where it's a much more diffuse field. So the stereo field is a lot less critical in terms of your centre point.
Gotcha. So I guess, Angus, that experience really opened your eyes up to the difference the time domain can make when it comes to audio reproduction. I'll let you pick up the story from there.
So it did. It had a profound effect on how I understood audio, and obviously the fact that we went ahead and designed that live end dead end room, and I felt it was a really successful process. I went on to live in Los Angeles and work in a lot of Westlake style studios, and I was always really affected by how I would hear those rooms compared to the live end dead end room that we did at Sing Sing. I think the other thing too that's worth mentioning alongside this is that in the early days, back in the 70s and early 80s, there was a huge focus on the time domain, so we were always talking about rise time and settling time of microphones and speakers, transient response. It was something that was probably, I think, the most popular conversation piece in those days when it came to audio. People would because we were challenged in terms of systems in those days. It was all modular in those. It was 45, 60s, Roy bins, 60-degree horns, 90-degree horns, W bins, and you'd put that all together and there was a lot of great advantages in those styles of systems, but one of the things that you were always striving to do was get efficiency and get fidelity, and we found that the most crucial part of that equation was your time response, and so being able to get good microphones that had fast rise time and fast settling time and so on, for me was a really crucial part of the picture. So that kind 80s, of encapsulates that.
Yeah, so that takes us through the 80s, and I think the next big...
Well, what I remember of the 80s.
Well, let's move straight into the 90s then. The next big epiphany, as you describe it, is when you took the Supertramp gig which introduced you to a reasonably obscure PA designer in France.
Christian Heil, yeah. Well, I guess, if you look just prior to that, I'd done a lot of touring through the late 80s and sort of up to the mid-90s with, Crowded House and a bunch of other people. And as a consequence, I'd toured all over the world and used pretty much every PA that was available. In those days, there was very heated competition between, the big players then, which was Clare Brothers S4, Turbo Sound with the TMS3s, and then the Flashlight Floodlight, Martin, MSI. There was a bunch of guys, but they were all making multi-source, fairly large format systems. And, the performance of those systems really came down to how well they were set up. They all suffered the same issues, but certainly a good system engineer could really create a great outcome compared to a bad one, and that came down very much to how stuff was set up. Yeah. But it was very kind of random. You could never really rely on getting a fantastic outcome because the predictability of the behaviour of the systems wasn't, what it's obviously become, in later times. So yeah, in '97, I got a. Well, actually, I should just preface it. The keyboard player with Crowded House was a guy called Mark Hart, who's a wonderful man, a dear friend of mine, and Supertramp decided to reform and go out. And Mark was good enough to put my name up to do front of house, and as a consequence, I flew to Paris to preview this brand new system from Christian Heil called VDOSC. And that was a real epiphany. I mean, it was, the first time I'd ever seen or heard it. And, we went to the Zenith Theatre in Paris where they set up, I think, like eight cabinets aside, and I went in there. They had an XL4, Midas XL4, and I took in my case of CDs and started previewing the system. And I was astonished by what I heard. I mean, it was remarkable, what Christian had managed to do. So, he and I was really lucky, actually. I got to spend a week with Christian sitting in cafes around Paris, looking at his AES papers and talking to him about the technology and really getting to understand, what it was that he'd attempted to do. Because, of course, he's a nuclear physicist. And, in fact, as a part of that role, I don't know if you knew this, he came to us. He was drafted into the army in I should say the diplomatic corps prior to all of this, and spent 2 years in Canberra as the attaché for nuclear weapons.
No, I didn't know that.
For France in Canberra, and of course he was without anyone hearing saying, I know nothing about. I'm a nuclear physicist, but I don't know anything about bombs. So he said he spent 2 years driving around Canberra in limos, drinking champagne and entertaining Australian girls, which I thought was a lovely story. Yeah, but anyway, so we had a great week, and I was really, very lucky to spend that time with him and get deep into the technology and really understand what he'd done. And of course, for anyone that doesn't know, what he'd done was rather than using physics of sound, he used optical physics to come up with a lot of the concepts that became VDOSC, and this is the DOSC wave guide and a lot of the concepts in how he arrayed boxes and created the coplanar symmetry and all the rest of it. So it was extraordinary, and that's obviously what we ended up using. I did the first world tour with VDOSC, and it was a great experience. He solved so many of the problems that existed with multi-source arrays, that were working in an XY axis, where you'd have this sort of uncontrollable, conglomeration of sound, and a lot of what he did, I thought, was profoundly correct and changed the way audio behaved. Now, I've got to add a caveat here, because one of the issues with VDOSC and with all line arrays that came after VDOSC was that as I became more confident and more experienced in using it, I found that if you could see light between two cabinets, you had big problems.
Right.
There was very large nodal influences created between two cabinets where the waveforms would interact, and particularly around 400, which was always a problem in that system anyway. So what it meant was that, as you moved in the horizontal plane, there was a far more linear distribution of audio. So as you moved from left to right, it was a really nice experience. As you move from the front to the back from close to the system to the back of the room, there were still serious issues with the distribution and the combination of the audio from those adjacent boxes created serious issues.
Yeah.
Now
that wasn't the promise, though, was it, Angus? Like, the promise was that the array effectively acted as one large speaker, so long as all the components were a half step or closer to each other. That you kind of effectively got this one big cheese wedge of sound, but the reality was different.
Well, that's right. And, from sitting down with Christian and talking to him about the concept of it, and all of the wonderful nomenclature that evolved from his designs with coplanar symmetry, and I forget some of the other ones, but there was a lot of very specific nomenclature that evolved out of what he'd done. And I guess I wanted to believe it, but the proof, the actual practical application of it wasn't quite as perfect as he would have had us believe.
It was a lot better. That was.
It was so much better. It was night and day. And look, I did some amazing gigs on the Supertramp tour, and I had people come to shows and listen to it and sit down with me and go, how is this possible? And and I'd do the best I could to explain the technology. And one that remains with me, which I thought was pretty funny, was we were in the States and Gene Simmons from KISS wanted to meet me and talk about it, and we sat down for probably half an hour and I explained the technology, and he's just sitting there nodding, going, yeah, look, it's amazing. And then at the end of the conversation he said, well, it's just a pity we can never use it. And I said, why? And I said, it's, you understand why it's so good. And he said, it's too small. He said, our fans would kill us, He said, it just doesn't look big enough. And I went, okay, whatever. So, it's kind of weird because,
Metallica was one of the first earliest adopters from memory, and they got away with it.
Yeah, that's right. Well, in fact, it's interesting because I was a consultant on the Metallica shows with Big Mick here in Australia, and also on Van Halen. So I'd been, L Acoustics Christian had asked me to sort of work with the company, and I did some stuff in Japan, a few other places. But yeah, it was it's a funny situation when you've got someone that's used to such big systems and you put this up, 16 boxes aside with good amps and good processing, and they hear it for the first time and they're just like, wow. It was, and I guess, from my point of view, as I say, I worked for Christian for quite a while after that as a consultant, and you do drink the Kool-Aid. There's no question. You do. So the disadvantage of this, to sing the praises of the positive element of the system, which were very clear and very apparent and worked.
Yeah. So, but you realise that there were some deficiencies, or it wasn't just magically perfect in every single regard.
No, and we became very skilled at setting it up so that those inadequacies would diminish somewhat. I was lucky enough to work with a guy called Sharif El-Babari, who is now the head of the ELISA program for L Acoustics, who, in my opinion, was the best system engineer in the world. He used to do fantastic, work for me with Supertramp, and he was just a joy. But notwithstanding that, at the end of the day, there was still things that it couldn't do, and I guess, what prompted me to write the article, I'll step forward quickly, was the fact that what people were led to believe as being gospel and being science, I found out at a later date, wasn't.
Okay, so let's work through that perhaps. And, I guess one thing that we know about all line sources, there's a heck of a lot of processing that goes on in the background.
Yeah.
And also that every single manufacturer of any note has bought into it, maybe with the exception, of Function 1, which kind of still does its own thing, even though it looks a bit like a line array.
Yeah, look, that's right, and I guess we should step back a little bit because in the '97 World Tour Supertramp, we used BSS processing and analog processing, and I got to tell you, because I obviously at that point was doing a lot of testing and stuff, the EQ curves and processing within that were pretty scary. I mean, there was some really vicious, processing applied, to get it to behave in a reasonably linear manner. And one of the interesting things too, which applied then and still applies now, is that, with a line array, when you've got lots and lots of HF drivers, all adjacent and allegedly working as a ribbon of a single driver, the amount of gain applied to the HF to get a linear response over the system was dramatic. I mean, and I used to add to that in my system EQ to get the kind of gloss and the kind of HF response that I felt sounded right for me. And even in the analog domain, that was apparent. When in 2002, when I did the next World Tour with Supertramp, everything was identical: same amps, same speakers, different processing. We had digital processing on the front of house, and immediately I heard a dramatic difference in the intelligibility, in the projection of the sound, in the depth of the soundscape, of the sound stage. All of these things changed, and I really fought with it for a while, trying to figure out what was going on. And I'll be honest with you, I don't know if I ever did figure it out during that tour. It might have been quite a bit later that I had that sort of second epiphany. But what I did, struggle with was that, there was a real crisis of confidence, actually, because I'm thinking initially, well, you've just lost your chops. Your ears are gone and you're just not the mixer you were back in 97. It was all fresh and it was exciting and you were riding on the crest of the wave. Yep. And I thought, well, maybe you just lost your mojo. Thankfully, that wasn't the case, I don't think, because, I did realise down the track that it was the digital processing very clearly that was creating the issues. And, I could demonstrably prove that when I went back and looked at the things that I was hearing that weren't stacking up against the analog processing that was being used on the 97 tour.
Yep. Yeah. So where does that take us on your journey? You went the last sort of 15 years. You've had a bit of a career change, and then you came back to the audio industry. Welcome back, and you started to get exposed, I guess, to KV2, which is doing it very, very differently. I guess, how did you get introduced to KV2 and what was that journey like? Well,
actually, before we go there, can I just quickly cover because I did work for Avid for a while, when I joined was DigiDesign, and I got a position there as the head of sales, believe it or not, for their live digital platforms, which of course was the Profile, which went on to become huge globally. I think on the back of Clare Brothers buying 200 of them, that just launched them into the stratosphere. And to this very day, they're still regarded as a extremely reliable and user-friendly platform. My favourite console, and it's one that I'd used with dozens of acts, around the world, was the Midas XL4. For me, that was a benchmark in quality in terms of analog, in terms of any mixing console. Had some fairly interesting quirks with the automation, but sonically, it was just a beautiful sounding console. The silkiest, glassiest top end of any live sound console that I've used. There's some other good American ones, but they were very bespoke and not commonly available. But anyway, so I got asked to join Avid, and immediately was taken with the power of these consoles and what they could do, particularly with the plug-in capability that had come obviously from the Pro Tools world within Digidesign, but more so the power and the integration with Pro Tools. They did so many things that no one had done before and did it very well. I can say quite safely in hindsight that sonically they were not a patch on a lot of good analog consoles, in particular the XL4, but they offered so much in terms of network capability, versatility, power in terms of channel count, outputs, flexibility in configurations that, I didn't have any trouble selling them. And again, drinking the profile Kool-Aid, or the venue Kool-Aid. I did find that as other companies started releasing consoles, that we did struggle from an audio point of view against, the Midas releases, Studer, Soundcraft, even Digico, had some clear advantages particularly in the HF, and in the quality of the bus sound and so on. Still didn't compete because we'd sold a lot of them. No one else was doing plugins the way we did, where you weren't relying on on manufacturer generated ones. We could use any number of other manufacturers' plugins.
Sorry about that.
That's all right. Any other number of plugins from manufacturers that were available, through the Pro Tools platform. So anyway, someone really wants to talk to you.
Yeah, sorry about that. I'll just keep on hitting the red button until they go away.
That's all right. Yeah. So anyway, that was the reason I mentioned that was because, it was my first real kind of dive into digital, and it reinforced my feeling that whilst it created an enormous amount of power in terms of networking and functionality and size. When I was touring with two XL4s, I was taking up the size of a small, or a reasonably sized lounge room. With all of a sudden with the profile, you could just pop it on a desk, and so real estate was a big issue. It ticked a lot of boxes, but it's still, it left this lingering doubt in my mind about the quality of digital sound and what it did to audio.
Was some of that down to just clocking? Like, I remember when the PM1D came out. Obviously, that was much earlier, but one of the first things the pros did was put a Apogee clock, external clock source, and that really kind of tightened things up considerably. Was that still an issue, like at that point, 10 years later?
It was discussed ad nauseum, and everyone had their favourite way of clocking things and doing things, and we used to do listening tests in San Francisco at the Digidesign offices and change the thickness of power cables, because Japan had said, when I put this big monster cable cable between the power inlet to the transformers, it changed the sound. And I'm sitting there thinking, well, you've still got the same jug lead between there and the wall. How's it? But look, so I guess what I'm saying is, there were so many theories and so many bespoke solutions that purported to make things better than they were. My philosophy pretty much my whole life has been, if you're a good engineer, you can make anything sound good, really. And I mean, that might sound a little trite, but at the end of the day, it's the ears translating the tools that you have and the artists that you're working with to give you the outcome that's the right outcome, And I mean, I've done tours where I've had a different console and a different PA every night, and my belief as an engineer is that what you need to do is translate accurately and reproduce accurately the sound of the artist. So, my aim in any venue, with any system, with any console, is to make it sound the same night after night.
Sure. And
to me, that's the benchmark of a good engineer. So, in a way, I guess I ignored a lot of that stuff. I didn't buy into it. I don't think I ever tried another clock. I used to go, well, this is the product. The guys that have designed it are pretty clever. And there were hundreds of forums and discussions and arguments and opinions about all of that stuff. And I really just didn't buy into it. I'd listen to things and I go, well, I like the sound of that, or I like the sound of that. I can work with that. I mean, I did several world tours with Crowded House where we used profiles after we'd used the analog consoles. And, I got good results, I mean, always, because I understood the band, I understood the music, and I understood the technology that we were applying to get the results we needed. And I think at the end of the day, for me, that's what it's all about. It's about listening. Interestingly, when I was working for DigiDesign, I became a master instructor for them with the venues. And the thing that changed a lot between analog and digital was all of a sudden you've got a screen. You get these engineers that are sitting there looking at the screen and trying to make it look pretty. I used to just pull the screen out and say, stop looking at it. Use your ears. Did you ever have a screen when you were using a Soundcraft or a PM5D or not PM5D, a PM5, or any of the great analog consoles that were obviously the bread and butter?
Yep.
No, you didn't. You just turned knobs until it sounded good. You'd have your techniques, you'd sweep a frequency, you'd hone it down, you'd change the cue, and then you'd do your EQ. It's all of those sorts of practical, physical, and oral techniques that we grew up using disappeared. People started looking at screens and the minutiae of screens and trying to make it look nice and sound nice. I say, no, don't do that. Use your ears. People are not, they're not looking at the sound. They're hearing the sound.
Yes.
So anyway.
Yeah. That's true now as it was then.
100%. And, and I still, to this day, I will, if I'm doing a gig, I will try not to look at the screen. And it's a trap, I mean, the physical cues that now, I think I actually love the S6L, the new Avid analog digital console. I think it's a great piece of kit. But even with that, you get trapped because it's so nice to look at now, it's just this sort of visual cornucopia, and I'm like, no, stop looking, just close your eyes and, tweak those knobs. But yeah, it's look, and I guess a lot of guys now, never got a chance to mix on those great analog consoles, so they don't have anything to compare it to, and that I think is really sad. I think it's unfortunate that that you don't get to use that technology to really set a benchmark for what audio should sound like.
Yeah, true.
Yeah.
So
sorry, I'm waffling here.
I and equally I keep dragging you a little too forward with my questions. So, but I think now we're kind of getting to almost the nub of the argument, as it were. So I'll let you proceed. Okay, so
KV2. Where do I start? Okay, so I guess. You said something when we first started, which was that, that it's about point source. And I made a note immediately saying, no,
yes,
it's not
but
just
no,
about point source. Yes, but no, but yeah. So here's the thing. KV2 audio, I discovered when I was just first started working with Avid, actually, with DigiDesign. And as it says in the article that I wrote, I was at NTech or one of the trade shows, and of course everyone's trying to be louder than everyone else, and it's basically just cacophony. But I remember distinctly, I was on a break and I was walking down an aisle, and I heard in the distance this extremely clear audio over everything else, which was pretty much just, you know, a mess of sound. And I could hear this really clear audio coming from somewhere down at the end of the aisle. And I thought, oh, that's interesting, and I'm going to pursue that. So I walked down to the end of the aisle, and lo and behold, here's a little stand with KV2 audio. And I met the guy there, Dave Williams, who's still the manager of KV2 business in Australia, and he introduced me to their speaker systems, and the one that we were listening to was an ES1, which was really the first speaker that they designed. It's now 17 years old, and they call it the Swiss Army knife of speakers because it just does so much so well. But I was immediately struck by it, and I just said, I've never heard audio so clear as this in a speaker system. And anyway, long story short, I asked him whether I'd be able to use that system on a product tour that we were doing with Venue, with the profile. To which he said yes, and so we did it, and it was a huge success. And people everywhere were, because it was funny. What we did was we went around Australia, and every town we were in, we picked up a band. I tried to find just a nice little jazz combo, a 3 or 4 jazz combo, and we'd video them. We'd do a live sound thing. I had a 16-foot screen set up behind the stage, and then we recorded to Pro Tools with video and then play it all back through the same system. And the overwhelming comment was, what are you doing to the sound? And I said, this is completely uneq'd. There's no system processing. What you're hearing is exactly as you heard it coming from the band live. And there was this disbelief that this little tiny PA system could recreate sound so accurately and so perfectly. So that was my first experience with it. And at the time, it was funny because I was still a line array fanboy, and I was still doing a lot of stuff with acoustics. And I used to say to Dave Williams, Dave, you got to talk George into building a line array. He's never going to compete, if he just keeps doing these little point source systems. And Dave would shake his head and say, well, he just won't do it. It flies in the face of everything he believes. And I wasn't deeply enough into the technology then to understand why. I just kind of shook my head and went, what it is. And really in those days, they weren't building large format point source systems. They were all fairly small. So they started with the ES1, and then they went down to a 5-inch and horn. And it's only really in recent times that they've expanded the range to the VHD5, which is sort of flagship large format. But essentially, and there was a long time between then when I was asked to join the company. And during that period, I continued to work with all of the new line arrays that were released, going through all the acoustics, K1, K2, Cara, all the rest of it. And then, of course, D&B, J-Line, GSL, and every other manufacturer that jumped on the bandwagon and started doing line arrays. I must mention that really made Christian unique, and particularly with VDOSC, was the DOSC waveguide, which did, in fact, create a completely phase-coherent HF outlet at the front of the box. Yes. And this was what he proposed created a lot of the effectiveness of that system, and I agree with that. To a large degree, it solved an enormous amount of problems in a conventional exponential, sound pattern that would come out of a typical, horn, whether it was a 6090 or whatever. It didn't tick all the boxes we found out, but it was a big player. Now, what I found was that a lot of these other sound companies that were designing line arrays completely missed that. And either didn't get it or couldn't get around the patent that he put in place to create that DOSC waveguide. So for me, a lot of these line arrays that came after really, really didn't tick the boxes in that particularly the HF horizontal plane, which which VDOS had done so effectively. So I just want to mention that because, and I still believe that. I still think a lot of these companies are kind of playing,
they're not light source, basically.
They're not. They're not. They're just a whole lot of boxes put on top of each other. And I've proven it so many times in listening tests, so many times where, either on gigs I'm doing or where I've been to listen to other shows, and it's a complex technical thing, but it just doesn't stack up when you hear it. Anyway,
sure.
We can go into that in more depth.
Well, I think I want to just dive straight into, I guess the competing technologies. As sort of like, I know that the argument that we're talking about is KV2 versus the rest of the world, effectively, but just pretending for a minute that it's not KV2, but it's a way, it's a design philosophy, as it were, a technology. So what is that technology doing that is, in your view, superior to what the rest of the world is doing, and how is it in some cases inferior? Like, it can't possibly be superior to line source in every single regard, surely.
Okay, that's a really good question, and it's going to take a while to answer it. And there's a lot of components to that answer. So the first thing I would say is, okay, let's forget about KV2. Let's look at a guy who grew up in Czechoslovakia. He lived through the German occupation and then the Russian occupation. As a product of the Russian occupation, he went and studied at some Russian schools, who I might say we know zero about Russian technology when it comes to audio and to design and audio concepts and so on. So he was, this guy, George Krempera, who was the founder of a particular company in Czech, he was, what's the word I'm looking for? Brain fart here. He was given access to a whole lot of information that other people weren't, and that really helped, I think, to frame his view of the world when it comes to sound. And he was designing speakers and amps and stuff as a young teenager, or even younger, I think. Anyway, so his philosophy of sound embraced speakers way further down the track. His philosophy of sound came from a very intimate understanding of how sound works and of the human ear and what it takes to create and maintain that quality control, if you like, from the source right through to when it does hit a speaker. So, if you look at George's philosophy about sound, and I'll break it down, I'll make it as simple as I possibly can, and I cover this in that article that I wrote. In the early days, as I said earlier, all we really thought about in those days was time response, was rise time, settling time, attack time, transient response, all of those things that gave excitement and clarity to sound. And George's philosophy is exactly that. And I mean, again, if people choose to look further after this discussion and look into it, they'll see that we can prove all of this stuff time after time. If you look at any conventional processing nomenclature now, you won't find information about time. Right? It's no longer considered. And there's a very simple reason for that. Digital technology cannot process time in the way that analog technology can. And that's just an absolute truth. 96 kilohertz, which is the standard sampling rate for pro audio now, struggles to create the information required to reproduce accurate, transient and time-based information. It just simply cannot do it. And we can prove that time and time again. Analog response is or as we hear it in nature, contains all of the transient information and time-based information that we need to get perfect temporal resolution in sound. Now, so temporal resolution is not frequency response. It's not amplitude response. Temporal resolution is the time it takes from sound to hit our ears to hit our brain. Now, it's been proven in several studies that the human's temporal time response is potentially as low as 2 microseconds, but definitely as low as 10 microseconds. And I've actually recently read some studies which are showing that it's 5 and under microseconds. Okay. Now, if we look at that in a time-based picture, that corresponds to about 200 kilohertz in terms of a frequency.
Sure.
Now, we're not talking about frequency response here. We're talking about temporal resolution, which is the brain's ability to determine time.
Yeah, and 200 is obviously a lot finer than 96K.
Well, 200 is fine. 20 kilohertz, which is the acknowledged extent of human hearing, right? So people talk about 20 to 20, right? But we're not talking about frequency. We're talking about temporal resolution, which would be the equivalent of 200 kilohertz.
Yes.
Now, that means that to be able to accurately reproduce 20 kilohertz, you'd be looking at a digital signal that's vastly higher than 96 kilohertz, vastly higher. And in fact, in our studies, when George decided that the only way that we could create a time delay system to reproduce audio in a digital realm that's the equivalent of analog, he ended up using a PDM 1-bit sigma delta modulator running at we say it's 20 megahertz. It's actually 22 megahertz, which when you bring that back to a PCM solution is 7 times higher than 96 kilohertz. But it's 1-bit PDM, so it's it's what SD is based on. So that's the only place that we actually use digital.
Sure.
It's running at 20 megahertz. So essentially, again, I'm going to waffle on this because it's a deeply complex idea. But essentially what it means is that current digital technology cannot reproduce audio in a way that contains all of the information that we need to get an accurate representation of the original analog signal. It's just simply not possible. Now, if you take that on board and go, okay, well, fair enough, I believe that. What it means is that we get enormous distortion in the signal that's being processed. And I'm not talking about intermodulation or harmonic distortion. I am actually talking about harmonic distortion, but I'm not talking about conventional distortion that you'd associate, say, with an amplifier or a distorted preamp. I'm talking about the distorted artifacts in that signal between the original signal and the output of that D to A and A to D process. Now, the simple way to do that in a test is to measure the input, measure the output, create a sum and then look at the difference, sum and difference. And you can do this day in and day out with any digital signal and compare the difference from the input to the output, and you'll find that it's dramatically different. Okay? So let's just say we can accept that as a premise. We accept that temporal resolution is a fundamental player in the quality of audio, and that human beings' ability to be able to determine temporal resolution down to 5 microseconds has a huge impact on how we hear sound. Now, a simple example would be if you close your eyes and you imagine when you hear a mosquito flying around your head, your ability to be able to very clearly place that mosquito in a 3D space is based on your temporal resolution at 5 microsecond resolution and the arrival time difference between the sound of that mosquito flying around in your left and right ear. It's that natural binaural or 3D perception of sound. Once you break it down and you make that 96 kilohertz, all of a sudden that sound stage goes whoop and narrows down, both in width and depth. And your ability to be able to recreate that depth of sound in a digital environment is completely destroyed. Hence, now all of this interest in immersive audio from L Acoustics and DMB and all these other companies, because they're saying stereo is no good, doesn't work. There's no depth and no sound. You can't determine where something is in the sound stage. Well, hang on. I asked a question about that, and it's a very simple question. How many ears do we have? Right? We hear in stereo. In nature, almost every sound we hear is point source. A gun going off, a bird singing, a golf ball being hit, a car driving past. All of these things are point sourced. Our stereoscopy is created through our temporal resolution by hearing and placing that in a 3D space.
Yes.
Am I right?
Yes.
It's 3D because you're hearing it through your temporal resolution in your ears, but it's still a point source. So if we look at an orchestra sitting on a stage, our 3D, and I'm talking not amplified, just in a well-designed auditorium, our perception of that sound is based specifically on our ability to be able to temporarily resolve the source of that sound relative to each player's position on the stage. So when you go and hear a great orchestra, the audio combined with the reflected sound in that auditorium, which give you the total sound of the room, gives you incredible 3D aural experience based on what I've just been talking about.
Yeah.
The problem with digitally processed systems, whether they be line source, point source, multi-source, it doesn't matter, is that all of that time-based information has gone. It's been depleted to the point where now complex waveforms, when they're played through these systems, lose all of that resolution because of the digital processing. So we haven't even got to point source yet. Yep. We're even talking about point source. What we're talking about is electronics and the ability to be able to accurately represent audio to the point where it hits that speaker system.
Yes.
So enough about that. So this is George's philosophy about everything in audio. It must be able to accurately reproduce the natural sound of an instrument. That's how he tests everything. Right, everything he designs, and I love that because it's very, very musical, right, in its philosophy. So if we accept that we've got a whole lot of processing that we use now, which is essentially most of it's non-digital, apart from our digital processor we use in the 20 megahertz range. He also says in order to be able to represent and recreate transients at a point where the human hearing needs to be able to is able to let me rephrase that. We need to be able to process audio in amplifiers, for instance, at 1 microsecond or less in order to keep the system distortion down to a minimum. Because once we go away from the digital distortion, then we're talking about analog distortion caused through reproduction through transducers. Okay, so in order to reduce transducer distortion to the absolute minimal, you need amplifiers that are operating, with a rise and settling time of around 1 microsecond, because that then creates a signal that once it's translated through the speakers, to very, very low distortion in the speaker.
Micro or milli? Did you say?
Sorry, did I say milli? I meant microsecond.
Okay, it is actually micro. Right. Wow. Okay. Yep.
Okay, so we've covered the digital processing, or getting rid of that. Then we've covered amplification. Now we look at the speakers. So this is where we will talk about KV2 because of what George has achieved in all of these preliminary areas in the processing of the speaker the audio signal to where it hits the speakers. This creates a real problem. Which is that now your signal path is so pristine that any obvious inadequacies in your speaker system become incredibly obvious, extraordinarily obvious, because the speakers then start recreating exactly what that amplifier is producing. So if there are any inadequacies in your speaker system, they'll become very much highlighted. So George came up with he's come up with several very clever things. A couple of things in particular I'll mention, which I think have fundamentally changed the way speakers operate. NVPD, which is a nitrate vapor deposition, particle deposition. This is a way of treating particularly HF compression drivers in a way that reduces the resonance of that compression driver of the cone by treating it with what it is. It's a nitrate vapor deposition. So it basically covers the cone and changes the modulus of elasticity, or the vibration coefficient of the, and hardens it. You don't get any nasty ringing in your HF drivers. So this is the first thing that creates a completely new and much more powerful driver, because it's able to reproduce audio more accurately and at a high power. Now, I might add that this is being used by other companies now. It's manufactured by a company in Italy, and the big companies are using it, not with the same level of success, because they're not ticking all of the boxes that lead up to that. But that's one thing. Another thing which is quite extraordinary, which is also available for people to use, and people have tried and failed because they don't tick the other boxes, is a transcoil driver, which is something that George designed. He trained a lot of the top engineers at some of the big companies in Italy, who now design transducers used other big companies over the world. And one of the things he came up with was a transcoil driver, which is basically has a secondary coil which sits in the magnetic gap, and it's at a phase with the main coil of the skirts with the speaker, and essentially reduces the inductance of the speaker to almost zero. So once the speaker comes out and then returns, rather than there being that ringing in the speaker, the transcoil stops it dead. So there's no distortion, which is again what it is, caused by that over ringing. Now, again, if people are interested in this and they want to go to the website, they'll see all of these pictures, illustrations of this stuff at work and what it actually does to the audio. What it does is it reduces the transducer distortion to almost zero, 0.003%. So what it means is that once you put all of these things together, is you get extremely high efficiency, very low distortion, extremely high intelligibility, and basically great sound. And I guess at the end of the day, I could wax lyrical on a sales pitch, but it's not a sales pitch. It really is based on the technology.
Sure. But so, okay, just to kind of bring this home, what's your challenge to audio people? Like, what's your challenge to people who, that there is only one paradigm? So, if this is Angus, not the company man, but the sound guy, what's your challenge?
Oh, boy. I guess it's a really good question, actually. I guess, from 40 years of being an engineer, I hear, I've heard some incredibly good mixes on big PAs, on a variety of different PAs. I've done some great tours on non-KV2 and non-line source systems, I guess what I look at now, and we do need to mention VHD5, because that has changed the paradigm, in my opinion. For a long time, KV2 made speaker systems that were fairly small. They then went on and built a system called VHD2, which, when used in conjunction with a bunch of other products, was able to cover, probably up to 5,000 or 10,000 people, depending on the application. In recent years, and the project that I've sort of been closely connected to is the VHD5. It was really the reason I was brought into the company, because of my touring experience. VHD5, which is a point source system that's based on 5 speakers that sit on 5 boxes that sit on top of each other. The fundamental difference between that and a line array is that we have a single HF source, a single mid-frequency source, and a single low-frequency source, which is basically the whole array. It's designed in such a way that it does satisfy the requirements to be a point source, and uses some of the same technology. And when you look at the way line arrays, the LF frequency drivers in line arrays are arrayed, but essentially the fundamental difference is that all of the HF comes from 3 compression drivers on 1 manifold horn, and this is what creates the point source, single point source. Now, we didn't really go into the destructive interference that's created in line arrays. We talked about it a bit, but what this does that line array can't do is it creates a single point source, particularly in the HF. Well, it's in every band, but what's significant is the HF, because obviously once your your wavelengths get shorter, they become more crucial in intelligibility and in definition and throw. So what VHD5 has managed to achieve is this extraordinary intelligibility and linearity across the sound field. So it's the first PA system I have ever heard in my life in a large format where I can walk anywhere in a listening field from 100 metres wide to 130 metres deep, and there is no difference in the sound. There's certainly the conventional laws still are at play when it comes to losing sound over distance. Certainly not much, and we've tested that in an open field and proven that. But in terms of intelligibility, in the linearity of the sound, there is not another system I've ever heard in 40 years that can do this. And I might add, when we did the did you come to the demo we did? Or not?
No, regrettably.
You didn't?
Okay.
But
I recall it happening, yeah.
So we did a demo at the My Music Bowl, which is a particularly nasty gig for anyone that's mixed there. But, one of my associates, Tim Milliken, who I've known for a very long time and who's now one of Australia's foremost, live sound engineers and system system designers, he came down and God bless him, he stayed for 8 hours that day. And I couldn't help asking him. I said, why did you stay for 8 hours? I mean, you could have listened for an hour and nicked off like everyone else. He said, well, because for me to be genuine and honest about my impression of the system, I needed to do what I'll do in a festival, which is spend 8 hours on site listening to a PA at operating levels to really evaluate it. And I said, well, so what's your evaluation? He said, this is the first time in my career after 8 hours on a festival-sized system that I've got no hearing fatigue, there's compression, there's no pain. And in fact, he said, the system's only been shut down for 10 minutes and my hearing's returned to what I would consider completely normal. For me, that was profound. And to have it come from someone with Tim's bona fides was more impressive. It speaks about the lack of distortion in the system, particularly about the lack of distortion. Yep. When we do our big shootouts at the big trade shows in Europe and Asia, our biggest problem by a mile is that our apparent volume is less than the competition because distortion is louder than clear sound. If you listen to a distorted audio, it can be a much lower level but seem much louder.
Sure.
We find that we're hitting the meters and going above, the allowable level with a much, much higher transient response and a much lower apparent volume because our transient response is so pure and so high in intelligibility that we're hitting 120 and 122 dB while everyone's struggling to hit 114. But their volume sounds much louder and it's painful. It actually hurt. So anyway, for Tim to say that and go, and he said it doesn't matter what you spend on a line array. No one has come up with a solution yet that allows line arrays to cut through wind in an outdoor venue. It's just simply not possible. And I've used them all. I've mixed on GSL, I've mixed on K1, K2, Adamson, every brand I've mixed on in a big outdoor environment. And if the wind blows, that's it. All bets are off. You just simply lose the top end. I've done lots of gigs on big shows where, you're mixing at an average 40, 60 metres off the front of the stage. And if the wind blows, it's just like someone's turned the amps off, Well, that doesn't happen with VH5. We had a measured 15 kilometre an hour crosswind directly, 90 degrees to the PA at the music bowl, and we were 100 metres away and the top end was barely touched. You could just hear it, but I mean, if that was a line array, it'd be over.
So how do you get that kind of, that reach? How do you, with only 3 HF units compared to equivalent line array where there might be
32.
36 or something. How do you get that kind of throw?
Well, I'll try and make it really quick, because it is again a complex conversation. If you go back to what we talked about with line array, so Christian's original premise was that when you put all of these line array elements into a line array and then you curve them to allow for the difference in SPL and throw that you're trying to achieve. So, for instance, the top of your line array would be very straight,
yes,
and then you'd curve it around to accommodate the audience as you get closer to the audience.
Yep.
This assumes something, which is part of the premise of particularly acoustic line array technology, which is that you're creating a coherent wavefront, which is to say that you're creating an unbroken ribbon of sound that hits the audience evenly and emanates from one source. That is simply not true. It's just not true. I run a stage at One Adelaide for several years, and I tested this out, and I've tested it in a few applications, but this was a good one because it was a big outdoor show. It's I think a 10 or 12 element 10 element K2 system, and I basically turned on the HF in the top 4 boxes and turned everything else off, and then walked back. Now, clearly, in that setup, those HF boxes are going in a line, in a coherent line, about probably 8 metres above my head or 10 metres above my head. Now, if line array theory was correct, you would not hear that.
Right, just sail over your head.
Is that a fair comment? If they're saying it's a coherent line array, and that the sound, you're only hearing the sound of each box, and that there's no interference between each box, if that was true, and Christian always used to say 4 boxes minimum to get a coherent wavefront, if that was shooting above my head, I shouldn't hear it at all. There should be no audio at all. Not true. Anyone can do that exercise. Now, I'm talking about in a free field where there's no reflective surfaces to bounce that sound back to me. Right? It's in an open field. There's no interruptive surfaces between the emanation of sound from those HF drivers and my ears. So we can't be saying, oh, yeah, but there was reflections from the walls or the whatever. No, there is none. Okay? Now, to me, that is an absolute physical test of the veracity of the statements about line array technology. Now, if that's true, we've got a big problem here because the entire premise of what they're selling their products on is flawed. Now, we also know with line arrays that as your frequencies come down, and I mean it shows it in all of the programs, that there's a frequency at which that coplanar symmetry and that coherent line array functionality is no longer relevant, that below that frequency the signal starts to become omnidirectional. Well, I don't believe that. I believe that it's omnidirectional at all frequencies to a certain degree. Now, you're asking how do we do it in VHD5 versus 32 drivers. What you need to understand is that when you put adjacent drivers and combine the signal of those drivers, and you have, say, 10 elements with 2 drivers in each element, and they're all putting sound out, that if you accept my premise that there is no such thing as a coherent wavefront, and in fact that what they're saying is a 5 or 10 degree, or 0 degrees interaction between those cabinets, then every driver that sits next to the adjacent box is interfering with and creating destructive and constructive interference between each cabinet. As a result of that, you're reducing the efficiency of the HF in particular, and it does extend down in the mid-range, of those adjacent drivers to the point where you're having to have 10 times the amount of power to create the same output level as we're getting from a single driver. Now, if people want to go to the website and look at George's videos, they'll see him describe it far more eloquently and more completely than I have just said. But it is a physical fact. And that's why when we run, say, a VHD2 system, as we've done in recent times with a number of top engineers, a single 3-inch driver is covering 3, 4, 5,000 people easily, because it's 100% efficient and it's not fighting with another driver. Right? So in the same way, VHD5 has 3 3-inch drivers. We're getting an overall SPL of 105 dB at 130 metres with absolute clarity. Now, and furthermore, as I said, when you're looking at something like the demo we did with 100 metres at the Maya Music Bowl, if you look at a line array, again, because of all these adjacent drivers and the fact that wherever you're standing in the audience, you're going to be hearing the arrival time of all of those drivers at different times, right? So it doesn't matter where you stand, wherever you are, the relationship between each of those drivers and your listening position is different. It must be. It's physical. That's simple geometry. If you accept that, and then you look at what wind does, well, sound travels through air as a medium, and air is a fluid medium. Of course, we all know that. So if you move the air, right, the relationship between the sound that comes out of a PA system and the listener changes not once, but 32 times for each driver position in the listening position that person's in. So if the wind blows, all of a sudden this complex waveform is completely destroyed, absolutely destroyed. It was already hanging on by a thread to start with, but now because you've got this interaction between the fluid medium of air and the generative device, which is your PA and the listener, all of a sudden all bets are off. And as I say, you only have to go to a concert and listen to an outdoor concert to know that's true. This is not a theory. This has been proven time and time again by everyone who's been to a concert and been frustrated by not being able to hear the horns. Or they can hear them, and then 1 minute they're twice as loud, and the next minute they've disappeared. It's just nature of audio. So because we're talking about a coherent, intelligible point source, that sound goes through, and even though the wind is affecting it, it's only affecting one single point source, so a single frequency, or a single wavefront, if you like.
Sure. Now,
and that's how it works.
One thing that line array is proving to be really good at, as DSP and amplifiers get better and cheaper, albeit digital, is having multicellular line arrays that allow you to shape the sound to the space. This is really valuable in lots of circumstances, and I guess Martin is doing it well, and maybe EAW Anya is doing it well. What about the practical benefits of line source?
Okay, well, I don't buy that for a minute. Actually, I don't buy it for a minute. We did a demonstration at Frankfurt Messe this year, and we went up against DB Technologies, Anya, a lot of these companies. So there's a couple of things here. Firstly, they cannot control horizontal, right? They cannot, right? Horizontal dispersion is preset. We agree there?
Yes.
Okay. So we're talking about vertical dispersion.
Sure.
Right? Now, I've heard all the trickery with vertical dispersion, and I've got to be honest with you, the first time I ever heard, the first time we ever set up VDOSC on the Supertramp tour in '97 in a big venue was the Bercy in Paris, which is a 17,500 seat big, arena. And, we did all our pointing and everything, and I walked all the way up to the very last seat to where we pointed that top box to finish, and I stood up above it on the seats. I went, oh my God, that works. That's awesome. So again, what I would say is, it's effective to a degree, but here's the issue. Firstly, when you're talking about a controlled wavefront, you're only talking about, as we just said, down to a certain frequency, right? And only then to a very limited degree, because the frequencies above that, if we accept my premise that the destructive interference between each of those adjacent line array cabinets is creating a very, very confused and distorted sound field, if you then go, okay, if we accept that and we accept that below a certain frequency sound starts to become omnidirectional, the effectiveness of your premise about controlling the coverage of a system via electronic trickery is diminished significantly. Now, why is that? Because let's just say, look at any, say, Rod Laver Arena, all right, or any decent sized venue where you're putting up a big line array. So if you go, okay, well, here's the top of our control pattern and here's the bottom of our control pattern, right? And here's the horizontal coverage, which averages about 100, 110 degrees on a big line array, okay? If we go, okay, well, we've got this control within these parameters. My argument is really, really simple. If we also accept the premise that the sound coming out of these is highly confused because of the interference between the adjacent speakers, that means that the reflected sound you are getting from the floor and the ceiling and the walls is not a single point source being reflected. It's a very, very complex waveform being reflected in extremely complex ways that is simply going to confuse the sound even further. Now, I'll just give you a really simple example of this. We're in Prague doing the Prague Philharmonic Orchestra they have a huge outdoor show every year outside the Palace. And they had the VHD5 of the orchestra and the listening area probably stretches for about 150 metres down to the Palace, and then you can go around the corner into around the sides of two big buildings. So I wanted to walk around and have a listen to it all. So I was with my colleague Dave Croxton, and we've walked out of the immediate listening area, past the mix tower, right down to the bottom. Still, obviously the volume had dropped off, but it was still very clear. I said, I want to try something. So I said, I want to try something. I've got a theory. And I said, let's walk right out of view of the system. I don't want to be able to see it. All I want to be able to do is hear reflected audio, right? And we're talking about massive stone buildings, like, 6-story stone buildings with glass windows and the whole catastrophe. So we've walked around the corner and I looked at Dave and I said, that is absolutely unbelievable. I am still hearing a discrete reproduction of that audio in an almost unchanged form. I said, we should, if this was a line array, we would be just hearing absolute. It wouldn't be good. It just wouldn't be good. I said, we're standing 20 metres off the corner of this building, simply hearing reflections of that PA coming off the buildings. We can't see the stage or the PA, and that's all we're hearing. And it was extraordinarily intelligible. So that's my answer to your... and I just don't believe... Look, I've heard all these systems. We went up against Anya at Pro Light and Sound and crucified it. I mean, I'm sorry, I probably shouldn't say that, but I mean, we went up against Anya and it was just no competition. There is not... And again, another example of that. If you go to any big outdoor show or even indoor show, you look at the distance at which they start employing delay lines, right? Delay systems. We wouldn't be within a bull's roar of that. I was walking away from the stage at Pro Light and Sound with every system, and I did it with every manufacturer that was there. And once you hit 60 metres, 80 metres, it was all over. There was no clarity. There was no intelligibility. The tonal shape of the sound had changed. Everything had changed. The KV2 is the only one that maintains that extraordinary intelligibility.
Okay. Well, let's bring it back again to the Angus challenge.
Sorry.
No, it's all right.
I get passionate.
No, it's good.
It's
good. I just... again, want to divorce it from a sales pitch, as it were.
Sure.
It's if from one sound guy to another over a beer, how would you challenge that sound guy to reassess the way that they think about it, how they listen?
Well,
that's what it comes down to, doesn't it? Like you're a little bit like a Christian, 25 years ago. It's like,
nice analogy. Okay. Well, you know what? I hear what you're saying, but I actually would like to sort of derail that a little bit, because the fact is that the fact is there are some manufacturers out there that own this market now, right? And there are companies that have invested multiple millions of dollars in the products that these companies manufacture. And they have a vested long-term interest. And as a consequence, regardless of what an individual sound engineer will say, unless he has significant influence, it will almost always come down to what is available, what is on riders, and so on. So, it doesn't come down to the sound engineer to a large extent, because the sound engineer is at the mercy of the promoter, of the sound company, of the manager of the band, and so on. But more so than anything, to the manufacturers of these systems, because they will do anything within their power to not let someone else new come onto the block. Sure. Now, line array technology is such now that, if you go to a trade show, there'll be 250 line array manufacturers and one point source. There'll be Danley, TW, there'll be a couple of others, there'll be KV2. But the Kool-Aid has been so heavily spiked now, and people are, if you look at today's sound engineer population, 95% of them have come in since the advent of digital and since line array technology. I mean, I started in the 70s, but there's not many of us left. So, they've never really tasted any other Kool-Aid. They know what they want to drink, and that's it. And I think there's an existential threat against people's whole philosophy when you say, hang on, there is something that's better, and you're challenging their entire value system and saying, well, no, what you're doing, it could be better. What you're using could be better. So that's really, as I say, the existential threat that stops people changing and wanting to change, because firstly, they've got millions of dollars invested. Secondly, they don't want to have their bubble burst. It'd be like, you used a Christian analogy. It'd be like someone coming up to me and saying, well, you've been a Christian your whole life, and I can actually prove that there's no such thing, but prove it. And you'd be going, that's rubbish. I don't want to hear about it. Go away. People don't want to hear that. Yeah. My challenge is to get a great engineer to take this great system out and do a great tour with it and turn heads and win awards, and for enough people to go, that is the most extraordinary experience we've ever had. Because interestingly, the people that are fans of this technology are absolutely diehard fans. I mean, we've got a guy in Brisbane who's now installed over 300 of these products, KV2 products, in venues around Brisbane and around Australia, actually, because the company who he works, who his company works for, is convinced there just is simply not a better sounding system out there. So that's speaking pretty loudly about. So for me, the challenge to an engineer, we'll go back to your original question. My challenge is to an engineer: listen. Just listen. Give it a chance. Take it out on a show. I'll give this challenge now. If there's one engineer out there that's prepared to give this VHD5 system a shot on a big show, I'll provide it delivered, set up, tuned, free of charge. Doesn't need tuning, actually. Tunes itself. But free of charge.
Wow, okay.
That's my challenge right now.
If anybody has made it all the way through to the end of this...
Which I doubt. I'm probably more deadly than coronavirus, mate.
If they made it through 90 minutes of this and they've heard that, that'd be amazing. I'd like to hear the next installment.
Hand on heart.
That's good, Angus. Hey, let's finish it there. Thanks for your time.
I really appreciate it.
Let's see whether anybody comments, because it's intentionally argumentative, which is fair enough.
It is.
Yeah, it's intentional.
And you know what? I want to rattle a few cages, and I'd really love to see what people's response is, because hey, everyone's got an opinion.
Yeah, exactly. What do they say?
Yeah, they're like,
Okay, won't go there. All right. See you, Angus.